Hi everyone! Today we're starting a new module, Module 2, and I had mentioned in our welcome video that once we get past chapters 1 and 2, we're going to mix things up a little bit. So you'll notice we're covering different sections from different chapters for this module, and we're mostly focusing on atoms, elements, and matter. So if you want, there's a study guide, and you can find that under Modules, Study Guides. All right, so we're going to start with Chapter 3. And again, this is all about matter and energy. So remember that matter is everything around us, and we're going to start classifying everything around us into certain categories. So matter can be classified according to its composition. So we either have pure substances or mixtures. So pure substances have a fixed or definite composition. And then mixtures contain two or more different substances that are physically mixed but not chemically combined. So what that means is, let's say you have sand mixed with salt. So they will physically mix together, but they're not going to have a chemical reaction with each other. So they're not chemically combined. Okay, so that's our example, sand with salt. No chemical reaction. All right, so now let's focus on pure substances. So within pure substances, we actually have two more categories or subcategories, elements and compounds. So a pure substance is classified as a type of matter with a fixed or definite composition, like we just saw in the last slide. So that can either be an element that is composed of one type of atom. And an example of that is aluminum. So an aluminum can is shown to the right, and that just consists of many atoms of aluminum. And there's nothing else mixed in to that aluminum, so it is a pure substance. Or a pure substance could be a compound that is composed of two or more elements or types of atoms. And they're always combined in the same proportion. So a really good example of a compound is water. So water has a chemical formula H2O. Now H2O is a compound because it has two different elements, hydrogen and oxygen. So H stands for hydrogen, and there are two of them. And then O stands for oxygen. So there are two different elements, which means that that is a compound. So again, elements are pure substances that contain only one type of material, such as copper or lead or aluminum. Those are just a few examples. Now, if we look on a periodic table of elements, you'll find that there are 118 elements. So all of those elements can be considered pure substances as long as they're by themselves and not mixed with anything else. Now off to the right, we have a handy chart showing how we can classify matter. So we said that we can classify it as either a pure substance or a mixture. And then right now we're focusing on pure substances, and we said we can either have elements or compounds. So one example of an element, again, is copper. So if you have a penny from before 1983, those were made of pure copper. So pennies made before 1983 approximately are pure copper. However, pennies that are made after 1983 are not pure copper. It's, I believe, zinc coated in copper. So, um, yeah, so pennies, you have to look at the year to see if they're pure copper or not. All right, and then compounds. Let's talk about compounds. So a compound, again, contains two or more elements in a definite ratio. So we already went over the example of water. Water has two elements that are in a defined ratio. So there's always two hydrogens and one oxygen in water. But there's some other examples listed here as well. So if you use hydrogen peroxide at home to kind of clean out cuts and scrapes, you can also use it to clean up some stains. That is always going to contain two hydrogens and two oxygens per compound. And then table salt, so the kind of salt you use at home on your food, that always contains one sodium atom and one chlorine atom. And then table sugar has three different elements in it. There's carbon, which is represented by a capital C, and then hydrogen and oxygen. However, they always exist in a ratio of 12 to 22 to 11. And so this is just the typical sugar you would use at home in your coffee or tea. So off to the right is a picture of hydrogen peroxide, and this is a 6% solution, although the kind you might have at home is usually 3%, I believe. So H2O2, hydrogen peroxide, is shown above, and this is kind of what its structure looks like. So the two oxygens are connected together, and then each oxygen is connected to a hydrogen. And we'll talk more about formulas and how chemicals are bound together later on. All right, so we just saw the example of table salt on the previous slide. So table salt, again, is a compound that contains the elements sodium and chlorine. So if we were able to separate the sodium and the chlorine from each other in our table salt, we would get pure sodium metal, which is gray and shiny, and chlorine gas, which has kind of a yellowish green color to it. Now you can also go in the reverse direction. We could combine sodium with chlorine to make sodium chloride, which is table salt. Okay. Now let's talk about mixtures. So a mixture, again, is a type of matter that consists of two or more substances that are physically mixed but not chemically combined. So a mixture can contain two or more substances in different proportions, and those substances can be separated by physical methods. So you should be able to separate components of a mixture through, again, physical means, which means that you're not going to use a chemical reaction to separate them. So for instance, on the right is one type of separation that can be performed on a mixture, and this is filtration. So this is kind of similar to how you would make coffee. You have some filter paper and you're pouring water or a mixture through that filter paper, and you're just going to collect the solution in the bottom, or the liquid. And then if there's any solid particles, for instance, those will just be left in the filter paper. So that's one physical separation that we can perform. Another option is just evaporation. So let's say you have a container with some salt water. If you let that sit out in the sun for a while, Eventually the water will evaporate and you'll just be left with little particles of salt at the bottom. So that's another form of physical separation where you don't have to do any chemical reactions to separate the mixture. Now there are two different types of mixtures. So on our chart on the right, under mixtures, you'll notice there's two categories or two subcategories, homogeneous and heterogeneous. So let's start with homogeneous mixtures. So in a homogeneous mixture, the composition is uniform throughout. So it's really hard to tell that you have a mixture when you have a homogeneous mixture. So the different parts of the mixture are not visible. So one example of a homogeneous mixture is brass. So brass looks like it's pure, right? It's all one color, it's shiny, it seems to have the same properties throughout. However, brass is actually a mixture of copper and zinc atoms. And so up above, you'll notice if we were able to zoom in on brass, we would actually see a mixture of different atoms. Now, another example of a homogeneous mixture that we might relate to more is, for instance, a cup of tea with sugar in it. So if you have a cup of tea with sugar in it, the sugar is dissolved, so it's kind of spread throughout. And it might be really hard to tell that there's any sugar in your tea. So that's another example of a homogeneous mixture, where there's two or more components, but you can't actually tell the difference between them. So I'll put sugar dissolved in tea. Now, right now I'm actually drinking some coffee, and I put some creamer in my coffee, and the creamer is mixed thoroughly in with the coffee, so it's hard to tell that there's even creamer in there other than the color change, but it all looks like one uniform solution. So that would be a homogeneous mixture. Now, another type of homogeneous mixture, or another example of one, is if you've ever gone scuba diving, you might have needed a tank of oxygen mixed with some other gases. So breathing mixtures for scuba are homogeneous mixtures. And so some examples of those mixtures are nitrox, which is a mixture of oxygen and nitrogen gases. Or I think this is pronounced heliox, which is a mixture of oxygen and helium, and then trimix, which has oxygen, helium, and nitrogen. Now, let's say these tanks over here that the scuba diver is holding were clear, so we could see inside of them. Gases are so small and so spread out, and they don't have typically a color other than like chlorine gas does, but oxygen, nitrogen, and helium are all colorless gases, so you really can't see them. And so it would be really hard to tell that you have a mixture of gases. So that is also an example of a homogeneous mixture. All right, now for heterogeneous mixtures. So in a heterogeneous mixture, you can see the different components. So the composition varies from one part of the mixture to another, and the different parts of the mixture are visible. So for instance, what if we just dropped some pennies into a cup of water? We would definitely be able to see that the pennies are different from the water. So that would be a heterogeneous mixture. Another example, let's say that you've mixed salt and pepper together. pepper is black and salt is white. So you would definitely be able to see the different components in that mixture. So that would be another example. So again, remember there are many different ways to classify matter. So first, you can classify matter as either a pure substance or a mixture. And let's say you have a pure substance. You can further classify it as an element or a compound. And then let's say you have a mixture. You could further classify that as a homogeneous mixture or a heterogeneous mixture. Okay, and then we went over a few different examples of each, but we'll also go over some practice problems. And here's one now. So let's identify each of the following as a pure substance or a mixture. And if you want to pause the video and try this on your own, feel free, and then we'll go over it together. Okay, so let's look at A, pasta and tomato sauce. Is that a pure substance or a mixture? A mixture, right? We have two different things there. What about B, aluminum foil? Is that a pure substance or a mixture? That's a pure substance. So it's just made of aluminum. What about C, helium? Is that a pure substance or a mixture? A pure substance. So if we had a periodic table of the elements in front of us, helium is one of the elements on the periodic table, so that would be a pure substance. And then what about air? This one's a little tricky. So air is actually a mixture. And later on we'll talk about what air is composed of, but we can also do that here. So air is made up actually mostly of nitrogen. It's about 78% nitrogen and about 21% oxygen. And then the other 1% is a bunch of other gases. So things like argon, there's some carbon dioxide, and a few others. So air is a mixture, but what kind of mixture would it be? Would it be a heterogeneous mixture or a homogeneous mixture? A homogeneous mixture, because we can't see the different gases that are mixed together. So that one's a little tricky because we often think of air as just one thing that we breathe in, but it really is a mixture of all types of gases. All right, and here's the solution slide. Now let's do one more. Identify each of the following as a homogeneous or heterogeneous mixture. And again, you can pause the video if you want to try this on your own first. All right. So let's work on A. A hot fudge sundae, would that be a homogeneous or heterogeneous mixture? And one thing to remember, homo means same, hetero means different. If that helps you remember which one is which. So A would be a heterogeneous mixture. Unless, of course, you let everything melt together, and then it would be a homogeneous mixture, right? All right, so what about B, shampoo? Is that homogeneous or heterogeneous? Homogeneous. Unless you're using some really cool shampoo, Shampoo is usually just, it looks like just one solution, but it's actually made up of multiple chemicals. Kind of similar to our discussion on toothpaste from chapter 1. Toothpaste looks like it's just one thing, unless you have the kind that has the blue and red in it, but for the most part, toothpaste looks like one substance or a pure substance, but it actually has multiple chemicals in it. All right, what about C, sugar water? And let's assume the sugar is dissolved. So that would also be a homogeneous mixture. And then what about D, peach pie? Heterogeneous. So we've got the crust, the peaches, so there'd be different components in that mixture, and we can actually see the different components. All right. And then here is the solution slide if you need that later. And next time, we're going to go over states of matter and their properties. So for instance, when we were talking about density, we saw that we had gases, liquids, and solids, and we're going to talk a little bit more about their properties and those states of matter in the next video. So I will see you then.